Ever feel like the tech world speaks a different language sometimes? Like you need a shortcut to really get the concepts behind the apps you use every day without getting lost in jargon. Well, today, that's what we're doing. Welcome to the deep dive, our mission to unpack one of the, well, really fundamental ideas in modern software, containerization and microservices.
Hmm.
We're going to explore what it is, why it's become so essential, and the key tools involved, all from the sources you shared.
Yeah, and this deep dive is, I think, really crucial. Understanding containerization gives you a fast track to seeing how today's, really big scalable apps are actually built. We'll try to turn that complex info into something clear, insights you can use, helping you understand the backbone of so much of the digital world.
Okay, let's unpack this then. When we talk about containerization in microservices,
Huh.
what are we actually picturing? The sources use this analogy, right? Like packing an app into a portable box that can run anywhere. What does that really mean in practice?
Right. It means taking a microservice like that small, independent piece of a bigger application, maybe user login or a shopping cart,
Yeah.
and you wrap it up with absolutely everything it needs to run. We're talking software libraries, specific settings, system tools, the works. It's like a self-contained little package designed to be consistent.
And the key thing, what's really interesting, is how lightweight these are compared to older methods. Unlike, say, traditional virtual machines,
Right.
which need a whole operating system each time, containers share the host system's core, the kernel, but they still keep their own separate space inside. So the magic is they don't have all that OS baggage. Yeah.
Absolutely. That's the core of it. Being lightweight, sharing the kernel.
Hmm.
That's why they start up in milliseconds, use way fewer resources, and the practical impact. Huge. It makes these microservices super easy to build, to test, and then crucially to move between different machines, like from a developer's laptop to a test server to the cloud. And you don't have to worry about them breaking or acting weirdly. It just guarantees consistent execution.
That run anywhere idea sounds pretty revolutionary. Can you give us a solid example? Maybe for like a big online store with lots of different parts.
Sure, yeah. Think about an e-commerce site. They might have one microservice for processing payments, another for product recommendations. Now, these could be built using totally different tech one, maybe Python for recommendations, Java for payments, but each one can live quite happily in its own container. This keeps them organized, stops them interfering with each other, no more conflicts, and it makes updates or fixes way simpler. You can tweak the recommendation engine without ever touching or risking the payment system. It really simplifies debugging and deployment.
Okay, so if I'm getting this right, it's not just about packing things up. It's the guarantee that what's inside runs the same, wherever it is. That gives you independence, portability, and just much easier management for all these separate bits of an application.
Exactly. That's the essence of it.
So these self-contained boxes sound great, but why did we need them? What problems were they solving in software development that made them so essential? What was it like before?
Well, before containers really took off, deploying apps could be, well, a nightmare. The phrase, it works on my machine,
Mm.
that was the reality. You'd build something on a developer's laptop, move it to testing, then production. And tiny differences in those environments, a slightly different library version, maybe a missing dependency, would cause these frustrating, hard-to-find bugs. It was this constant battle against what we call environmental drift.
Right. So a huge reason containers took off is this consistency across environments. They pretty much kill those works on my machine problems because they package everything the microservice needs right with it. So it runs the same everywhere. It carries its whole environment inside.
Precisely. And that directly enables the next big thing, independence and isolation.
Hmm.
Microservices often use different tech stacks, like we said. Python here, Java there, maybe go somewhere else. Containers keep them totally separate. They can't interfere with each other's libraries or settings, and that's critical for stability. If one microservice crashes, it doesn't take down the others or the whole application. It's like having, watertight compartments on a ship.
That isolation sounds incredibly valuable, and it must mean faster development and updates too, right? Developers can just focus on their small piece, build it, test it in its container. They can update just one microservice, add a feature, fix a bug without touching anything else. That must speed things up massively and lower the risk.
It really, really does. I remember times when deploying an update involved, like crossing your fingers, hoping the server environment hadn't changed. Containers just make a lot of that pain go away. And talking about handling change, scalability is another massive win. Imagine a big online sale. Suddenly, the checkout service is getting hammered with traffic. With containers, it's incredibly easy to just spin up more copies, more instances of just that checkout microservice to handle the load. You scale only what you need when you need it. And that on-demand scaling is absolutely vital for modern apps. It can literally make or break a business during peak times.
And that ties into efficient resource use as well, which we touched on. Because they're lightweight, unlike VMs needing a full OS each, containers use way fewer resources,
Okay.
less memory, less CPU, which means you can pack more microservices onto the same server hardware.
And that translates directly into cost savings,
A
right?
significant cost savings, yeah. Fewer servers needed, lower cloud bills.
Okay, so pulling all these benefits together,
hmm
what does this really mean for someone building apps or even just someone using them every day? Well, it means containerization makes sure microservices work reliably everywhere. It keeps them separate and resilient. It dramatically speeds up how fast developers can build and update things. It lets apps scale up and down really quickly, and it saves money on resources. It's just a fundamental shift in how we build robust, efficient software today. It helps explain why the apps you use feel so available so fast and are always getting new features.
Okay, so we get what containers are and why they're so important now. Let's get practical. What are the main tools, the platforms that actually make this container magic happen?
Right, the tools. Well, the first name you'll almost certainly hear is Docker. Docker is really the dominant player for creating and managing individual containers. Think of it as the tool that does the packaging. It takes your microservice, its dependencies, and bundles them into that portable container image, ready to run on any system that has Docker installed.
And Docker got so popular not just by chance, right? It's known for being relatively simple to get started with. It runs everywhere, laptops, servers, clouds, and there's this huge community around it, tons of support, great for beginners dipping their toes in.
Exactly. It really lowered the barrier. But then, when you have lots of containers,
Mm.
maybe hundreds,
Mm.
running across many servers,
Yeah.
you need something more. That's where Kubernetes comes in, often just called K8s. If Docker builds the boxes, Kubernetes is the foreman,
Yeah.
the orchestrator. It manages fleets of containers across clusters of servers. It handles all the complex stuff, automatically starting them, stopping them, scaling them up or down based on load, handling updates without downtime.
Right. So Kubernetes is the powerhouse for running microservices at scale, especially for bigger, complex applications. It's like the traffic controller and the health monitor, ensuring containers are running, balancing the load between them, even automatically restarting any that fail. It's pretty much the standard now in many companies for managing these complex systems reliably. But thinking about a smaller team, maybe just starting out, does jumping into something like Kubernetes add a lot of complexity? Is there a big learning curve they need to factor in?
That's a really good point. And yes, absolutely. Kubernetes is powerful, but it's not simple. There's definitely a learning curve and some operational overhead involved in managing it. However, for applications that need to scale and be highly reliable, the benefits it provides, the automation, the resilience, often outweigh that initial complexity, especially long term. And beyond Docker and Kubernetes, there are other important pieces in the ecosystem. You've got tools like Podman, for instance. It's similar to Docker in many ways, but designed with maybe a stronger security focus, and it doesn't need that central background service, which some people prefer. Then there are container registries. Think of them like libraries or warehouses for container images. Docker Hub is the most famous public one, places where you store your built container images, share them, maybe pull down pre-built ones for common software.
And of course, the big cloud providers are all over this. AWS, Google Cloud, Azure, they all offer managed container services, right?
Mm.
Like AWS has ECS, Google has GKE, Google Kubernetes Engine. These basically take away the headache of managing the underlying servers. You just focus on your containers.
Exactly. They run the Kubernetes control plane, or their own orchestration system, for you. Makes it much easier to run containers in the cloud.
So yeah, to kind of sum up the tool landscape, Docker is often where you start for building and running individual containers. Kubernetes is the go-to for managing lots of them in complex, dynamic environments. And then you have registries for storing and sharing images and cloud platforms offering managed services to simplify the whole thing. These tools are popular because they work, they're well tested, they have huge communities, and they fit nearly any kind of microservice setup you can think of. They create a really solid foundation.
And there we have it, a deep dive into containerization in microservices. We started off defining containers, those portable, self-contained boxes for microservices, packing up the service and everything it needs to run consistently. Then we dug into why they're so crucial today for consistency, isolation, speeding up development, enabling that critical scalability, and using resources efficiently. And finally, we looked at the key tools making it happen, like Docker for the building blocks and Kubernetes for managing the whole orchestra. Yeah, and understand this stuff isn't just for techies, you know? It's about getting a handle on the architecture behind so many of the reliable, fast, constantly improving apps you interact with every single day. These technologies really have changed the game for modern software development, making incredibly complex systems manageable and efficient.
It really is fascinating how far we've come in deploying applications. Makes you think. If containers let us package and run services literally anywhere, what does that imply for the future? Especially for truly global apps running across all sorts of different computers and clouds. What new kinds of possibilities does that ultimate portability unlock next? Something to maybe ponder as you go about your day?